scaling up instance segmentation using approximately localized phrases. I'm Karan, and this is joint work with Ishan Misra, Justin Johnson, and Lawrence Vandermartin. Existing object detectors do very well when trained and evaluated with a limited set of object classes. But if you are to scale them to many more object classes, it becomes challenging because they require masks and boxes for every object class they need to be evaluated on, and these are expensive to collect. So, our motivation here is to scale such models rapidly, and we aim to learn to segment novel object classes, but we do not use any training masks or label boxes for any of these classes. So in this paper, we propose a task setup where we use natural language supervision for acquiring novel object classes, and we introduce a very simple model to handle the noisy supervision of such annotations. So in summary, we train instance segmentation models using a combination of mask annotations for a few base classes and something we called approximately localized phrases to acquire novel classes. So first I'll walk through the data and then the model and then finally the results. So ALPs, approximately localized phrases, are just natural language phrases that are paired with boxes, and these boxes are derived from some rough localization signal in form of mouse scribbles or clicks. We use the recent localized narratives dataset to get like 2.7 million ALPs, and when put in context with COCO, these phrases cover 240 novel classes that are not in COCO. Our model is simple and straightforward, extending FCOS. We extend FCOS model and add a mask head to perform instance segmentation. Specifically, we add a very deep hourglass mask head, which is the recent state of the art in segmenting novel classes with unseen training masks. We also extend this model to add a clip-based open vocabulary classifier to flexibly handle the variations in natural language phrases. And our motivation to use an FCOS-based model as compared to mask RCNN, which is the existing standard, is that FCOS utilizes center-based matching and a center noise regression as an auxiliary learning signal. It draws a lot of training supervision using box centers instead of box area or edges, which is typically used in mask RCNN for intersection over union based matching. We believe that the rough localization of ALPs still has their box centers close to the true centers of the underlying objects. And this type of training supervision makes it less sensitive to the noise in imprecise ALP boxes. We simply train this model using alternate batches of masks and ALPs, and we also introduce a very simple training time augmentation which randomly distorts the box edges of ALPs to maximize the coverage of the underlying object so that the model gets better supervision during training time. Here we just show one key result from the paper, but there are many more in the paper. We have a comprehensive evaluation in the paper. Here we train mask RCNN and FCOS, our own FCOS based models using COCO masks and different forms of supervision for novel classes. And we aim to segment 300 classes from open images, out of which 60 classes are base classes in COCO and 240 are novel classes. And we observe two main results. First is that when all the models that use ALPs, the second and third row here, they outperform an open vocabulary baseline, which only trains with masks on base classes, uses no annotations for novel classes, and simply relies on a pre-trained clip model to align its representations to learn novel classes. And the second observation is that when we train with ALPs, FCOSMO outperforms a mask RCNN baseline, especially on novel classes. This shows that our model is better able to handle the noisy supervisory signal in ALPs. And here we display some qualitative examples from our ALP supervised FCOS model. And we see that the model produces reasonably accurate masks, but most of the failure modes stem from poor classification rather than poor mask quality. Please find more details in the paper and visit our poster if you are attending in person. Thank you.